Hey, this is Randy Hintz from New Kent Robotics, head coach for Team 16537 Logic Coyote, and providing a code review for code that was sent from Team 3668 Smokey Jr. Got a text from Zane. Mr. Zane is a mentor for both teams. And the message says, having issue with motors on robot, direct to battery works fine. Through RevHub and programming, the motor is jerky and can stop it with your finger. So, didn't click in at first when I read this message, but upon reflection, I realized that probably the motor was being set to 100%, then later in the code being set to 0%, that 1 to 0, 100 to 0, I'm sorry, 100 to 0% setting was being run over and over and over again, and that was causing the behavior that Mr. Zane was seeing. So with that, let's go look at the code that was sent. So the first thing I want to point out is this method right here, public void loop. So this method is defined by the team and is called multiple times by the FTC controlling program. So this loop is called multiple times per second, probably hundreds of times per second. And the code just runs from there all the way down to here. That's the end of this loop method. And again, this code is just run hundreds of times over and over again. I want to skip down to, well, let me just first point out here up at the top, they've got a series of statements here defining some booleans, defining a couple of floats. These statements grab the gamepad conditions and save them to variables. So I'm saving to a variable called X button, B button, etc. And then I'll be able to examine these variables later on. Good practice, nice way to make it easy for yourself to access these variables later on. Now let's scroll down, and I want to concentrate our efforts right now on looking at these statements right here, this set of statements underneath the comment driving, but more precisely. This is the code that the team is trying to use to control their motors. Pressing the up button will drive the robot forward. Pressing the down button will drive the robot backwards. They've dumbed it down because they're trying to figure out what's going on here. So let's step through the code right now. Let's do a step through and let's assume that the D-pad up is being pressed. So right here, if up, that's going to evaluate to true. The up is being pressed if up evaluates to true. What does that mean? That means that this code inside of those two brackets, this code now gets evaluated. So it is setting the power on both of my motors to 100%. So if up, set my motors to 0. Keep falling through the code. The next thing is an else statement. The else is directly tied to this if. If up, if not, then do this. Well, we know that if up is true, so the else evaluates to false. We do not run this set of code right here. So we fall through. We fall through to right here. Now, if down, if I'm pressing the up button on the D-pad, if down is going to evaluate to false. So if down evaluates to false, this set of code does not get run. If down, else, notice there's an else that corresponds to this if statement. If down is false, my else statement then evaluates as true, and I'm now setting the power to 0. So you can see what happens when the up is being pressed. I set the power to 1 and then immediately set the power to 0. And because this code is running multiple times per second, I am continually setting the power to 1, setting the power to 0, setting the power to 1, setting the power to 0. If I have the down button pressed, the same thing happens but in reverse. Is up true? No, it is not. So I do not run these statements, but I do fall into the else loop. And I set the power to 0. Is the down pressed? Yes, it is. So I set the power to -1. I'm running the motors backwards. The else does not evaluate, and I keep on falling through. So again, when the down is pressed, set it to 0, set it to -1, set it to 0, set it to -1. Over and over and over again, I am continually running that code in that way. So as you can see, this is not what we want. What do we want? What we'd like to do in this case is to actually use an else if statement. So if you look down below, the team actually did have something similar down here on the opening of the left finger. But let's concentrate again. Let's stay up here on this code and look and see how this can be fixed. So what I'd like to do at this point to add the else if is to actually just right here delete that section of code, and I end up with this. If the up is being pressed, set the motors to this. Else, if the down is being pressed, set the motors to this. Else, set the motors to 0. What this gives me now is a set of code that says if one condition is true, do one thing. If a second condition is true, do a different thing. Else means if both conditions 1 and 2 are false, then run this code. And that's the only time I'm running this code. The only time I'm running that is if this evaluates to false and this evaluates to false. What's really nice is I can actually add multiple else if statements. So I can say else if left, else if right. And I believe I've got that correct. That's what they called them up here, correct? Up, down, left, right. Yeah, when I was looking at the statements earlier that grabbed the gamepad, I only highlighted this top section. I did miss the D-pad selection. But here it's left and right. So now I can say set motors for right movement. And sorry, that should be left. Set motors for left movement. Set motors for right movement here. Now again, I can look and do my walkthrough on my code. If the up button is being pressed, I run these statements. Else if down is not being pressed, else if down is not being pressed, left is not being pressed, else if right is not being pressed. And of course, these are all inside of else statements anyway. As soon as the first condition evaluates as true, Java will automatically fall through and not even examine each one of these. So if up, I run these statements, else, 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 Java falls through all of those else statements and simply picks up here and falls down. So if the left is being pressed, Is up being pressed? No, fall down. Look at my next else. Is down being pressed? No, fall down. Is left being pressed? Yes. Run this set of code. You'll have to add the code for that. Then it will skip through this else, skip through this else, and fall right on down. If I do not have anything pressed on my D-pad at all, my D-pad is currently inactive. This evaluates to false, this evaluates to false, this is false, this is false. Then it will hit my else loop and set my motors to 0, which is what I want. Now, all that is good, but I do want to point out one other thing in this code that was sent. So this is all underneath driving more precisely. This is probably the code that the team will want. But looking up above, driving in your 4 directions, you'll notice that here is some code again. All this code falls through. It runs every single time. This code is also setting the power on these 2 motors. I've seen this code before. My guess is this came from the sample code provided by FTC and was left here by accident. We need to get rid of this code. We do not want any of this code. If you want to add some telemetry data, then you need to figure out what that is and add it based upon what you need. But that telemetry data is strictly based upon this code and this driving method. So you'll want to just get rid of that code completely and be done with that. You don't need that code out there. The next thing I want to point out here is going down. So we've got the open or close the clampers, opening the left finger, opening the right finger. Then we've got the lifting the arm up or down. Notice here, if bumper is this, else we're setting it to 0. If bumper R, else we're setting it to 0. This code is structured the same way that the driving more precisely code was coded before I made the changes that I just did up above. So you will want to examine this and make this match the same kind of changes that I am suggesting in the driving more precisely area. Bottom line, you want to take the code that controls a specific motor or a set of motors that's controlling an assembly, like you've got 2 motors for your drive. Here you've got your set position for your claw R. Here you got your set position for your claw L. And you're going to want everything that controls a specific motor or a set of motors to be contained inside one single group of if, else, if statements. If, for instance, you have you've got some code up here that's setting your motor inside a group of if, else, if statements, and then you're setting the motor again down here, now you've left yourself open for setting it once, setting it twice inside the same set of code. You definitely want to avoid that. The other thing is you don't want to have your up, down, left, right, and then continue with your else ifs and start looking at your B button, your Y button, etc. Because again, the else means as soon as it finds one that's true, it's not going to look at any of the other conditions. So as soon as the up is being evaluated as true, if you had it in the same set of if, else, if statements, your X button would never be found as long as your up was being pressed. So those are the 2 big things to avoid when using this programming methodology. So team, I hope this helps. I hope you're able to get the code working the way you'd like to. Definitely, you've got my email address now. If you have other problems, feel free to send me the code. Let me know what's going on. I'll be happy to provide another walkthrough and give you any more feedback.